So I expected the lead buckshot here to heat up by about 2.5 degrees Celsius, and well, it was close. It heated up by 1.4 degrees Celsius. Some of the energy must have dissipated out. It must have leaked out and heated up the glove instead of the lead. I'll try this
Maybe you
again.
need a minute instead of the glove.
Yeah, or maybe I need to drop it. Oh, actually, that's true. I mean, it might be nice to have a perfectly insulated glove, right? And so that really all the heat that goes into the lead stays in the lead. But anyway, so you get the idea that we dropped. Here, let me just drop it one more time. We measured the temperature. We dropped the bag of lead buckshot from a height of 3.4 meters. We did it 10 times just to give us a measurable effect. And right, so up here we've got potential energy, MGH, and we drop it just before it hits the ground. It's all coherent kinetic energy. All the molecules are moving, in the same direction down. Now when it hits the ground, it doesn't go down anymore. The energy dissipates. So everything's just jiggling incoherently. The same amount of kinetic energy, but instead of everything going down together coherently, everything's jiggling incoherently. That's thermal energy. So that MGH, which started out as gravitational potential energy, became 1/2 mv squared just before it hit the ground. And then all those 1/2 mv squareds sort of went into different random directions. And we have the mass times the specific heat times the temperature difference. And okay, we predicted 2.5 degrees C, and we measured 1.5 degrees C. I think I'm going to have to drop it 100 times instead of 10 times next time to see if we can get it to work a little better.
What about elastic collisions? Well, it won't heat up.
Oh, right, yeah, so if this thing were to collide elastically with the ground, right, this is a totally inelastic collision because afterwards the relative velocity of the glove and the floor is 0. If this were to collide elastically, then it wouldn't heat up. Then none of the energy would be dissipated into thermal energy. It would just, if it was a super ball instead of a bag of buckshot, it would bounce back up, ideally to the same height that I dropped it from, although even a super ball loses a little bit of energy into thermal energy. Now this is something, so while we're here, this is, I think, to demonstrate the power of radiation, right? So you've got sigma times the area times temperature to the 4th power. Heat. So this is energy being transferred to you from this light bulb already. You can feel that, right? You can actually feel the heat from this thing. Right? If you get something of a really high temperature, like 6,000 kelvins, like the sun, then it's really quite a bit of radiated power. So I just brought these things in as kind of a warm-up act.